Electrical power. Electric power is the rate at which electrical energy is transferred by an electric circuit. The SI unit of power is the watt, 1 joule per second. Superiority of electrical energy. Electrical energy is considered superior to all other forms chemical, heat, light, sound, or mechanical of energy due to these reasons. Conventional form, easy control, greater flexibility, cheapness, cleanliness, and high transmission efficiency. Coming to one by one, cheapness. It is much cheaper than that in other forms, and therefore it is economical to use energy in this form for domestic, commercial, industrial, and agricultural purposes. Convenient and efficient transmission. The electrical power can be transmitted conveniently and efficiently from the generating stations located quite away from the centers of usage through conductors of suitable size. Easy control. Electrically operated machines have simple and convenient starting, control, and operation. For example, an electric motor can be started or stopped by making the switch on or off, and its speed can be conveniently controlled over a wider range with simple arrangements. Next one, cleanliness. The use of electricity, electric drive, or electric heating does not produce smoke, fumes, dust, or poison gases, and therefore its use ensures cleanliness and pollution free conditions. Coming to the greater flexibility, electrical energy offers greater flexibility as it can be taken to any corner of the house, factory, street, hospital, farm, mine, etc. through solid, standard, or flexible conductors. Next one is the versatile form. The electrical energy is a very convenient form of energy and it can be easily converted into other forms of energy, heat, light, mechanical, sound, or chemical. For example, electric lamps, especially fluorescent tubes, give to rise pleasant and cheaper light as compared to that produced by the lamps of other types and can be located at any desired place where other lamps cannot be kept due to the danger of the fire or due to some other reasons. Sources of energy. The sun is the main source of energy on earth. Other energy sources include coal, geothermal energy, wind energy, biomass, petrol, nuclear energy, and many more. Energy is classified into various types based on sustainability as renewable energy sources of energy and non-renewable sources of energy. What is energy? The classical description of energy is the ability of system to perform work, but as energy exists in so many forms, it is hard to find one comprehensive definition. It is the property of an object that can be transferred from one object to another or converted to different forms but cannot be created or destroyed. There are numerous sources of energy. The sources of energy can be classified into renewable sources, non-renewable sources. Now coming to the sun. The sun is the primary source of energy. The energy radiated by the sun is in form of electromagnetic waves which include the heat, light and a lot of ultraviolet radiations. The radiated heat energy by the sun can be utilized for generation of electric power. The steam can be produced by focusing the heat over a boiler by the same reflectors. This method is inconvenient as it requires a larger area for the generation of even small amount of electrical power. In our country, conditions for utilization of solar energy are favorable since for nearly 6 months of the year sunshine is uninterrupted during the day and useful energy estimated at noon is 12,000 kilowatt per kilometer square, while in other 6 months cloudy weather and rain provides conditions suitable for water power. Thus, coordination of solar energy and water power can be useful and workable plan for the most of the places in our country. Coming to the second source, the wind. The winds produced by the sun got sufficient energy which can be utilized in windmills to drive small generators. Such generators are used for charging batteries for continuous use. The great advantage of this source of energy is that it is plentiful, inexhaustible, non-polluting and it does not require any operator. It also does not require any maintenance and repairs for long intervals. In our country, this source of generation of electrical energy will prove economical a number of places as revealed in a recent study undertaken by NAL Bangalore. Coming to the third one, terrestrial heat or geothermal energy. The earth has the molten core. During the volcanic action, the material that comes out from the bowels of earth to form volcanic explosions also produces steam vents and hot springs. This steam has been used for many years in different countries like Italy, Ireland, and France for the generation of electrical power and space heating. There are a number of hot springs in India, but the total exploitable energy potential seems to be very little. It is proposed to set up cold storage and power plant based on geothermal energy at Manikaran, as experimentally 5 megawatt plant is proposed in Porga village, Ladakh. Coming to the another source, ocean tides and waves. There is a tremendous energy in the ocean tides and waves, but it is very difficult to harness this power for generation of electrical energy. Only at a few favorable points where the geography of an inlet or bay favors the construction of a large scale hydroelectrical power plant. In India, the potential for tidal energy exists in Gulf of Kutch and in southern of the West Bengal. Hydrological studies have indicated that power plants can be established on rivers Malta and Kalkan Krays in this region. The potential of tidal power also exists in the Cambay near Bhuvangar, while the tidal range of this order of 11 to 12 meters. Coming to the another source, water. Water at a high pressure or flowing with a high velocity can be used to run turbines or water wheels coupled to the generator, and therefore for generation of electrical power this method of generation of electrical power is becoming more and more popular as it is reliable and requires least maintenance and care. Thus, this method is costly in initial cost but cheapest in maintenance and production cost. Coming to the fuels, the main sources of energy is the fuel. Fuels may be solid, liquid or gas such as coal, oil and coal gas. The coal is available in huge quantities in almost all the industrialized countries. The coal is fired in the boiler, which produces the steam. The steam so produced is utilized in steam engines or steam turbines coupled to the generators and therefore for generation of electrical power. The average calorific value of coal is 6700 calories per kg. This method is most inefficient because of overall efficiency as low as 20 to 25% due to availability of coal in huge quantity. The cost per unit generated is not so high. The disadvantage of this source of energy for generation of electrical power is that it requires a larger space for storing the coal and involves heavy cost of transportation where the coal mines are away from the generating station. Coming to the another source, atomic energy. The tremendous amount of heat energy is liberated by fission of nuclear distinction of uranium and other similar fissionable materials. It is estimated that 1 kg of nuclear fuel is equivalent to about 2500 tons of coal. The heat energy is liberated in atomic reactors is extracted by pumping fluid or molten metal like liquid sodium or gas through the pile. The heated metal or gas is then allowed to exchange its heat to the heat exchanger by the circulation. In the heat exchanger, the gas is heated or steam is generated, which is utilized to drive a gas or steam turbine coupled to the alternators, thereby generating electrical energy. The capital cost of such generating stations are very high. These power stations are best suited in the areas far away from the collieries and where the alternative hydropower is not available in different areas. Now coming to the similarities between the renewable and non-renewable energy sources. They are both are natural resources and there are individual advantages and disadvantages. Both have be definable and make mind and the produce the energy. In the conventional energy sources, these sources are exhaustible, but non-conventional these sources are inexhaustible. In conventional, these resources cause pollution as they emit smoke and ash. But in non-conventional, these sources are pollution free. Sources of energy in India. The power sector plays vital role in the economic growth and human development of any country. It is definitely improves the quality of life of human beings and the biotic of this sphere. Electricity consumption is one of the most important indices for measuring the development of level of the nation. Power is one of the most crucial components of infrastructure and critical for the welfare of the nations. India's power sector is one of the most diversified in the world. India's power sector is one of the most diversified in this particular sources of power generation range from the conventional sources such as coal, lignite, natural gas, oil, hydro and nuclear power to vital non-conventional sources such as wind, solar and agricultural and domestic waste. Electricity demand in the country has increased rapidly and is expected to rise further in the years to come. In order to meet the increasing demand for electricity in the country, massive addition to the installed generating capacity is required. In 2022, India ranked 4th in the Asia Pacific region out of 25 nations as an index that measured their overall power. India was the ranked fourth in the wind power, fifth in solar power, and fifth in renewable power installed capacity in 2022. India ranked sixth in the list of countries to make significant investment in clean energy. India is the only country among the G20 nations that is on track to achieve the target under the Paris Agreement. Kerala, Karnataka, and Jammu and Kashmir are very rich in water power resources, and therefore power development programs should be based on this source. In Karnataka, three thermal units, each of the 210 megawatt capacity at Raichur, are already working. Atomic power plant capacity 470 megawatt 2 into 235 megawatt is already proposed in the Karnataka. In Assam and Maharashtra, the major sources of power is the water, and therefore power development program should be based on it. However, in Assam, the backing can be provided by gas turbine power plants using natural gas available locally, and in Maharashtra by the nuclear power plants. In Assam, four thermal units each of 60 megawatt capacity are already working. In Maharashtra, total installed capacity of the steam power plants is already more than 7,000 megawatt. Installed capacity of nuclear power plants in Maharashtra, Tarapur, is the 420 megawatt. In Punjab, Haryana, Himachal Pradesh, sizable potential of the water is available. Expansion of the base load requirement should be met by the nuclear power plants located in this particular area, in preference to the conventional steam power plants being uneconomical. However, this area can be backed from the steam power plants already located in Delhi, Haryana, and Punjab. The total installed capacity of steam power plants already operating in Delhi, Haryana, and Punjab are different ratings here. UP has the sufficient water power sources, and therefore this should be the main source for the power generation. The water power can be supplemented by the conventional steam power plants, and preferably located in the eastern part of the state. Coming to the Tamil Nadu is deficient of the coal resources, and it has already exhausted its limited water power resources. The future program should therefore be based on largely on the nuclear power plants. The installed capacity of thermal, hydro, and nuclear power plants in Tamil Nadu are about 4,420 megawatt, 1,125 megawatt, and 470 megawatt respectively. The installed capacity of thermal and hydro power plants in Madhya Pradesh are 6,500 megawatt and 590 megawatt respectively. In Orissa are 1,880 megawatt and 582 megawatt respectively. Gujarat and Rajasthan are deficient in both the water and coal resources, and therefore the nuclear power should be the main source of the power generation. However, in Gujarat, the small water potential and natural gas available can be utilized to meet the peak loads. The installed capacity of the steam, hydro, nuclear power stations in Gujarat are 4,010 megawatt, 420 megawatt, 470 megawatt respectively. In Bihar, as abundant of coal reserves, the major power development program should be therefore based on the conventional steam power plant. Small water potential can be utilized to meet the peak loads. The installed capacity of the steam power plant and hydro power plants are respectively 2,500 megawatt and 130 megawatt. Coming to the West Bengal is rich in coal resources and deficient in water potential. The power development program should be therefore be primarily based on conventional steam power plant. The installed capacity of steam power plants in West Bengal is 4,795 megawatt. As of July 2022, India has the total thermal installed capacity to 231.45 gigawatts. Almost 86% of the thermal power is obtained from the coal and rest from the lignite, diesel and gas. The private sector generates 46.9% of India's thermal power, whereas states and central generates 27.9% and 25.3% respectively. The electricity generation target of conventional sources for this particular academic year 2022-23 has been fixed and the billions of the units, that is growth around the 6.33% over actual conventional generation for the academic year 2022. This target comprises the different combinations. The power supply position, the growth in availability of electricity was 1.1% compared to the same period of the last year. This slide shows the growth of Indian power. In 1950, and local grid excised that fed a small generating station to nearby the loads here. And after that 1950 to 60s, growth of the state grids by the electricity boards, and coming to the period is 1960 to 80s, interconnection of the state grids to form regional grids along with the few interstate links across the regional boundaries, strengthening the regional grids through acts of the central sector projects. And after that in 1922 till date, and that is the national grid. The national grid means the generation of the projects with the beneficiaries across the region led the establishment of high capacity inter-regional links. So now here is an Indian power grid. Evolution of national grid. The national grid management on a regional basis started in the 60s. The Indian power system for planning and operational purposes is divided into 5 region grid. The integration of the regional grid and thereby establishment of national grid was conceptualized in the early 90s. Initially, state grids were interconnected to form a regional grid, and India was democrated into the 5 regional names: northern region, eastern region, western region, northeastern and southern region. In 1991, northeastern and eastern grids were connected. Further, in 2003, western region grid was connected with it. In August 2006, north and east grids were interconnected, thereby 4 regional grids are synchronously connected, forming a central grid operating at one frequency. On the 31st December 2013, the southern region was connected to the central grid, thereby achieving one nation, one grid and one frequency. All possible measures are taken to ensure that the grid frequency always remains within the 49.90 to 50.05 Hz band. The important frequency, the maintaining a constant electrical frequency is important because multiple frequencies cannot operate alongside each of the without damaging equipment. This has a serious implications when providing electricity at a national scale. Capacity of the national grid. Presently, the country has a total inter-regional transmission capacity of about 1,12,250 megawatt, which is expected to be enhanced about 1,18,740 megawatt by the year 2023. What are the benefits of the national one grid, one frequency? Matching demand, synchronization of all regional grids, which help in optimal utilization of scarce natural resources, by transfer of power from resources centric regions to the load center regions. And another benefit is development of electricity market. Further, this shall pave the way of establishment of a vibrant electricity market facilitating trading of power across the regions. This slide shows the interconnection with the neighboring countries. India being centrally placed in South Asian region and sharing potential political boundaries with the SAARC countries, namely Nepal, Bhutan, Bangladesh, and Sri Lanka, is playing a major role in facilitating planning of interconnections with these countries for effective utilization of regional resources. India has developed expertise in implementation of the HVDC and UHVAC projects, and it will be beneficial to connect the neighboring countries electrically with HVDC or UHVAC transmission lines. This shall give rise to mutual cooperation among the neighboring countries, nations, and resource sharing in the region. This will also ensure energy security of the region. India is already having interconnections with the SAARC countries. Coming to the India, Nepal. Nepal has been historically interconnected with the India at various places through 11 kV, 33 kV, 132 kV and 220 kV lines rapidly. The present power sector capacity, power transfer between the India and Nepal is about 600 megawatt. The Muzaffarabad, India, Dhalkar in Nepal, 400 kilovolt DC line is expected to be operated at its rated voltage shortly, which would further enhance the power transfer capability to the Nepal by 300 to 400 megawatt. Further, second high capacity 400 kilowatt Gorakhpur New Bhotal DC quarter line is taken up for the implementation of the facilities reliable transfer of power between the two countries. Coming to the India Sri Lanka. Cross border interconnection has been proposed between the India and Sri Lanka through 2 into 500 megawatt HVDC lines between the Madurai, India and New Arbana in Sri Lanka with overhead lines including sea portion in two phases of 500 megawatt each. The DPR per India Sri Lanka interconnection is under preparation. Coming to the India Myanmar, about 3 megawatt power is being supplied to the Tammu, Myanmar from Manipur through 11 kV line between the two countries. The feasibility of establishment of following low capacity interconnections is under preparation of the facilities power supply to its border villages. One is the Nambong, Arunachal Pradesh, India to Pasong, Myanmar. 11 kV line is being Manipur and in India, and next one the Chikka in Myanmar. 11 kV line one and another line between the Mizoram and in India and Rokapur in Myanmar 11 kV line. What are the challenges in power sectors? Here is power is one of the basic components of infrastructure that defines the country's economic development and quality of life of the individual. Out of all power resources available for consumption in India, thermal sources counted 67% of the power production capacity, 14% hydel and 2% nuclear power. Insufficient electricity generation. In India, the installed capacity to produce the electricity is not enough to support an annual economic growth 7 to 8%. Currently, India only adds 20,000 megawatt a year of the generated power. Poor infrastructure, too many power cuts in various parts of the country and huge power tariff. Lack of investments. When it comes to the power and energy, the private sector does not play any part or there are any foreign investors. The public sector is almost having a monopoly in the power generation sector. This slide shows the present and future energy scenario in India. In past few years, India has achieved an impressive growth in adding renewable energy generation. Efforts have been made to allocate a long-standing problems like power shortages, rural electrification, poor distribution companies, discom, financial health and non-performing energy assets through various policy investments. However, the current penetration of renewable energy is low, about 15% of total energy supply. The energy supply spectrum largely entail coal of about 50% followed by the oil and gas. It is enhanced that in 2050, India will have an annual energy demand about 14,500 terawatts per year. Largely, the demand will be from industry sector allowed by the transportation and buildings. In the absence of paradigm shift towards the low carbon alternatives, the dependence of fuel and will increase the causing of serious threat on nation energy security and GHG emission in the future. With the determined effort by the policy markets, India can overcome barriers to enhance the investment in clean and sustainable energy supply options. In 2050, India will achieve reliable, economical, competitive and environmentally sustainable electricity system, addressing the energy security and environmental strains. A couple of trends under current energy sector reforms are converging to create the game-changing distributions like electrification of large energy intensive sectors coupled with the accelerated renewable energy capacity, adding parallel efforts to strengthen the electricity supply to underserved and unserved through the integration of grid and distributed renewable energy, adoption of the emerging storage technology to increase the grid applicable to the accommodate intermittent sources that enhance the cost optimization through the best use of the automation and communication analysis. Clean energy in India has the top priority to meet the global commitment under INDC demand, that is intended national determined contribution to meet the target of reducing the GDP emission intensity by 35%. The reduction is made by the 2030 considering 2005 as a base data. With the aggressive change in INDC targets on renewable energy capacity addition, India can have more than 50% of electricity generated from renewable source, leading the global renewable energy generation in 2050. India is everything towards the massive electrification of its energy intensive sectors, the majority of which in 2050 will be seen to be supplied from the renewable sources like solar and wind. Ongoing efforts towards the greening of the passenger and freight transportation by railways and an abundance plan of electricity to enhance the entire road transportation by the year 2030 indicates that second most energy intensive sector, transportation is target. In 2050, the renewable energy system in India will have largely utilized scale RE projects connected to the central transmission grid to supply energy through open access to large industrial and commercial establishments. Some parts of it will be feed to the state utilization to fulfill their renewable purchase obligations. India assessing various storage alternatives to transform the transportation sector where lead acid batteries are prevalent technology. Electric vehicles technology has rapidly evaluated over the past 5 years and has witnessed dramatic decline in cost about the 65%. Low cost models of the Nissan Leaf, Volta, Tesla and making their ways of the distributed automobile sector. USA and China having a line share of about 70% of electric vehicle market. India through its new electric vehicle policies has plans to completely electricity its automobile sector by the year 2030. In the year 2050, India transportation network will be completely running on electric energy. India will have electric vehicles with a plug and play system where discharged batteries on lease or rent basis can be swapped with the rechargeable battery taking 2.5 to 10 minutes for four-wheeler to a large buses. There will be charging stations also set up concentrated areas such as shopping malls, cinema halls and restaurants. To achieve this, however, government has to incentivize and provide the tax breaks to support the electrical vehicles. On the other hand, penalties and capping with discourage diesel, petrol-based combustion engines. The operational barriers also needed to achieve the addressed, for example, settling of large-scale battery production units, transportation of the batteries to the rental and retail services centers, local electrical vehicle manufacturing capabilities and safety features, which requires the critical analysis of electrical vehicle policy.